Okay, so we're going to go over the chapter 1-3 practice test that we did in the earlier year. I'm going to record this video so you can watch the video to follow along the questions when you're having your own time on your weekend. So let's go through the questions. Question number 1. F of x is graphed in a dashed line. And the question asks me to sketch a graph of the transformed function g of x is equal to 2 times f of negative 1 over 2 times x minus 8, close bracket, minus 2. So when I see this kind of question, what I like to do first is to identify or write down and identify what each parameter represents. So the first thing I will do is that I write that a is equal to 2, b is equal to negative 1 over 2, c is equal to negative 8, and d is equal to negative 2, coming from the form a f of b times x plus c plus d. Now the question is, what does a, b, c, d represent? Well, we know from a long time ago, we know that we can use a graphic organizer like this. We call this a SRT organizer. The S stands for the stretch, R stands for reflection, and T stands for translation. And the VH, respectively, represents vertical and horizontal. So, my first question is, what is my vertical stretch? Well, vertical stretch and vertical reflection is determined by the A value. A value is 2, so simply vertical stretch is 2. And the vertical reflection is none, because A is positive. What about horizontal stretch and horizontal reflection? Well, the B value is negative 1 over 2, and that tells you about the horizontal stretch and reflection. Unlike the vertical stretch, the horizontal part is counterintuitive, which means instead of writing down 1 over 2 as my horizontal stretch, I need to find the reciprocal of it. So my horizontal stretch would be positive 2. And there is a reflection, because its AB is negative, that's like that. And watch out that A and D values they work differently, especially with the stretch part. And same thing will be applied for the translation as well. Now that I know the first 2 rows of it, let's figure out the translation. My C value is negative 8. And what does that tell me about my horizontal translation? Well, negative 8 means that for horizontal counterintuitive, it moves to the right by 8 units. And finally, the D value tells you about the vertical translation intuitively, so it's negative 2. Just to remind you that B and C, which is inside the F of brackets, that tells you about the horizontal things, whereas A and D, which is outside the F, tells you about the vertical things. So that's how you remember how to group those together. Now that I've analyzed the information, let's actually draw the diagram. Well, first thing that I'm going to do is I'm going to do the vertical stretch by a factor of 2. So what do I mean by vertical stretch by a factor of 2? It means that my graph is doubled in size vertically, and you can also think of it as the y value being doubled. So when 3, 0 is doubled, and the y value is doubled, it still stays at 0. But then the 7, 6, the y value is doubled, which means that 6 becomes 12. So that's going to be 7, 12. So if I roughly connect those 2 points together, I have successfully covered the vertical stretch. Now let's do the horizontal stretch. Horizontal stretch means that my x value is multiplied by a stretch amount. So we're stretching by 2. So I think it means that my 3 is doubled. So that's going to be 6, 0. And then 7, 12. The 7 will be doubled, so I'll have about here 14, 12. If I connect those 2 points together, that means that we've just done the horizontal stretch. Notice that I'm doing it one by one, going from up to down, because we need to go stretch, and then reflect, and then translate. Now let's do reflection. There is no vertical reflection, so we'll skip that. What about horizontal reflection? Horizontal reflection means that my x value is multiplied by -1. My 6, 0 becomes -6, 0. 14, 12 becomes -14, 12, roughly here. So if I connect those 2 points together roughly, that is after doing this reflection. If there was a vertical reflection, it means that y value is multiplied by -1. So we simply take the number and we multiply it by -1. That's it. Okay. Now let's do the final part, translation. Vertical translation by -2 means that the y value is decreased by 2. So we just minus 2. So what does that mean? My -6, 0, the y value is 0. 0 minus 2 would be -6, -2. -14, 12. Well, 12 minus 2 is 10. So it'll be -14, 10. If I connect those 2 points together, that is after doing the vertical translation. Final step. There's a horizontal translation by 8, which means my x value is added by 8. Let's start with -6, 2. So, -6, -2. -6 plus 8, it's 2. So that's going to be 2, -2. What about -14, 10? -14 plus 8 is -6. So that will be -6, 10. Not 16, -6, 10. And I connect those points together. And I think that is the completed graph, the transformed graph of the f of x after doing the transformation to f of -1/2 times x minus 8 minus 2. All right, moving on to the second question. F of x is graphed in a dashed line. Find the equation of the transform function h of x is equal to a times f of bx, b times x plus c plus d. So this time, instead of analyzing the information on the equation, we need to analyze the graph and see what happened exactly. Quite similarly, I'm going to use the same graphic organizer, VHSRT. And let's look at it step by step exactly what happened. The first thing that I'm going to analyze is the stretch, obviously. So let's figure out what was the vertical stretch. I measured the vertical stretch by comparing the two endpoints of the graph, or in using the jargon, we're comparing the range. The graph, original graph, f of x, goes from 0 to 6 in terms of y values, and my new graph goes from -8 to -2. Both graphs have the range of 6. So what does that mean? Well, it means that the vertical stretch is none, so we should say 1 is my vertical stretch. Notice that for the stretch, no stretch means 1, and for translation, no translation means 0. What about for the horizontal stretch? The domain, or the width of it, is 3 to 7, so it's 4. And my new graph goes from 4 to 8, so that's also 4. So I think that also tells you that horizontal stretch is still 1. Now let's think about the vertical reflection. Well, for vertical reflection, we need to use some spatial reasoning here. It seems like the graph is kind of going upwards and trend. We also notice that we go through this little point here. So after 1 point moving to the right, we go 3 points going upwards. And I see a similar pattern here with my new graph. going to the right by 1 and going down by 3. So I think overall it tells me quite easily that there is a vertical reflection. So let's say that there is a vertical reflection. Finally, the horizontal reflection. Well, if there were a horizontal reflection, my graph would be going downwards in a like this. That's not existent, so there's no horizontal reflection. Important thing to note for this type of question is after we analyze the stretch and reflection, before we move on to the translation, we need to do the graphing of the stretched and reflected version of this graph. So let's put a pause here and then graph this vertical stretch of 1, horizontal stretch of 1, and vertical reflection and no horizontal reflection. So if I do that, well, I'll skip the stretch because that's just 1. But now there's a vertical reflection, so that means that 3, 0, well, 0, the y value is multiplied by -1, so it's still 0. 7, 6, the y value is multiplied by -1, so it becomes 7, -6. Like that. After I graph this, halfway through transform graph, then I can find a vertical and horizontal translation. Let's think about the vertical translation in the perspective of this point 3, 0 and 4, -2. Well, ideally, if you did the first two steps correctly, the translation of all the points must be identical as well. But yeah, 3, 0 to 4, -2, it seems like we need to go to the right by 1 and go down by 2. So that tells me that horizontal translation is 1 and the vertical translation is -2. Just to do a quick check, let's also test another point. Going to the right by 1, going down by 2. So I do know that I've done my work correctly. Now I filled out the graphic organizer. Now it's time to translate this into ABCD coefficients. Well, let's start with A. The vertical stretch is 1, so that's good. But there is a vertical reflection, so I think that tells me that A value must be -1. For B value, the horizontal stretch is 1, and there's no horizontal reflection, so it's +1. For the horizontal translation, C value, remember that horizontal numbers are counterintuitive, so it must be -1. Finally, the vertical translation is just write it as it is, -2. So if I summarize them together, it becomes h of x is equal to negative f. By the way, last time I marked this test, about half people forgot to write the f, so don't forget that, please. Times 1, so I'm not going to write that. X minus 1, close bracket, minus 2. So my final answer is h of x is equal to negative f of x minus 1 times minus 2. So remember that the stopping after doing the stretch and reflection is the key part here. All right, moving on to the next question. Given that f of x is equal to 3 square root of x minus 3, find the inverse function of f of x. And let's sketch the graph of inverse function of f of x. So how do I find the inverse function? Well, there's multiple ways to write it, but I think we can write the easiest. If we rewrite the function with y equals 3 times square root of x minus 3, we do the swapping of x and y. Remember the swapping of x and y? So I'm going to switch x and y positions and say that x is equal to 3 times square root of y minus 3. Now, the process is to isolate y. So let's do it step by step. I'm going to divide by 3 on both sides. And then I'm going to square both sides. And finally, add 3 on both sides. So that is my inverse function of f of x. Now let's sketch the graph of this inverse function. So I have two options here. One, I can use the property of the quadratic function that I know of from previous years. So x squared over 9 plus 3, so y is 3, and it's a quadratic function going upwards. I could do that. Or I can use the graph of the f of x and inverse that. I'll do that because I think that's a bit more easier to use. So in order to graph the inverse of a function, we need to draw the line y equals x. That is a diagonal line going from the bottom left to the top right. That y equals x is a line of reflection. I will reflect my original graph onto the y equals x. Or you can also think of it, remember that when we found the equation, we swapped x and y? We can also do that here. We swap x and y for each coordinate. 3, 0, we swap it, it becomes 0, 3. Notice that I swap x and y. And I also swap 7, 6. So it becomes, well, guess what? 6, 7. And then let's connect these 2 points together so that it looks like a reflection over y equals x. So it wouldn't be like this, right? That's not a good reflection. I think it must go through something like that. I think that looks like a good reflection over y equals x, while also maintaining the overall structure of 0, 3 and 6, 7. And finally, I can also check this one more time by plugging in the values to my inverse function. If I plug in x equals 0, 0 squared divided by 9 plus 3 is indeed 3. 6 squared over 9 plus 3, 6 squared, 36. 36 divided by 9, 4. 4 plus 3, 7. So I'm happy with this inverse function and the graph of it as well. All right, moving on. Given that p of x is equal to 2x cubed minus 4x squared minus 10x plus 12, fully factor the polynomial and sketch p of x and label the intercepts. All right, I don't have much space. I'm just gonna copy this question down and do it with more room below. All right, so the first part of this question is to fully factor the polynomial. I don't know, I remember seeing a lot of people struggle with this question here. Whenever you encounter a factoring problem, the very, very first question you need to ask is there a common factor? And if you do that, your mathematical life will be maybe greatly simplified. Okay? So my first task, I will find the greatest common factor and factor it out. Do you see the greatest common factor here? I see 2. Let's factor out 2. And then let's get into it. So we learned in grade 11 how to factor, in grade 10 and 11, we learned how to factor quadratic functions or expressions, but we don't know how to do the cubic ones. So that's why we learned a new trick that we in pre-calc 12, and it's called the factor theorem. Okay. And also we know the integer zero theorem. What was that? What was the name of it? Whatever that is called. So what it means is the number 6 and the possible factors of number 6, including plus minus 1, plus minus 2, plus minus 3, and plus minus 6. These are the possible candidates of the factor of this polynomial. So how do I check whether these are pass or fail? Well, we simply compute p of that number and see if it works. So let's check on the side. Let's check p of my sidewalk here. Let's try p of 1 and see if it's equal to 0. So plug in 1 cubed minus 2 times 1 squared minus 5 times 1 plus 6. 1 minus 2 minus 5 plus 6. Oh, we're lucky. I think we got our answer for the first time. So we got p of 1 is equal to 0. Yay us. So now what? We know that using the factor theorem, we know that x minus 1 is a factor of p of x. Okay. So that plugging 1 and getting the result 0 means that x minus 1 is a factor of p of x. So I'll write the process on the main body here using the factor theorem. X minus 1 is a factor of p of x. So if I know that it is a factor, what do I do? Well, we need to factor it out. Well, how do I factor x minus 1 out? We need to divide, right? So how do I divide polynomials? That's where we use the polynomial division. I taught you two methods, the long division method and the synthetic division method. Personally, not a big fan of synthetic division. I still don't understand it. So let's just do long division. So how do I do the long division? Well, we write the x cubed minus 2x squared minus 5x plus 6, which is the polynomial that we want to divide by. And we write the divisor x minus 1 on the side. It's literally the long division that we learned in our elementary school. So let's start by x cubed. How many times is x going to x cubed? Well, tricky question. Is x goes into x cubed, x squared times. So after you write the number, we multiply x squared to x minus 1, x cubed minus x squared. And then do subtraction. X cubed minus x cubed is 0. Negative 2x squared minus negative x squared. Negative 2x squared plus x squared, so that's negative x squared. We bring down the minus 5x below. Now let's ask the question again. How many times is x go into negative x squared? It goes into negative x squared, negative x times. Negative x times x minus 1 is negative x squared plus x. Negative x squared minus negative x squared is 0. Negative 5x minus x is negative 6x. Bring down the plus 6. How many times does x go into negative 6x? Negative 6 times. And we got the remainder to be 0, which reassures that indeed x minus 1 is a factor of p of x. So let's proceed one step further. P of x now can be rewritten as 2 times x minus 1 times the quotient that we got, x squared minus x minus 6. Now I can do the factor theorem one more time, but I think that's quite inefficient given that the only remaining thing is the quadratic expression. We know how to factor quadratic expression, right? We're going to find two binomials, linear binomials of x, where two numbers multiply to negative 6 and add up to negative 1. Well, doing some trial and error, I think negative 3 times 2 is negative 6, and negative 3 plus 2 is negative 1. I think that's it. And there you go. I have completely factored p of x, which is 2 times x minus 1 times x minus 3 plus 2. It's a complicated process. Make sure you pay attention to each step that I just took here. The second part asks me to sketch p of x and label the intercepts. So let's do that. So in case you wonder, why are we doing this in the first place? So this is where things get a bit more interesting. Only after you do the factoring, we can actually draw the graph now. Without factoring, it is quite difficult to graph. So, first of all, let's start with the given information. The p of x is given in a cubic function where the a value is positive and the constant term is 12. So what does the constant term tell you? It tells you the y-intercept. So I know the first thing, that the y-intercept is 12. It's quite tricky here. Let's put 5 here and 10 here, and that's about 12 right here. That's basically the only thing I know about from the original p of x. So now let's look at the factored form. The factored form of the polynomial function tells you the x-intercepts. So from the x minus 1, we know that the x-intercept is positive 1. And from x minus 3, we know that another x-intercept is at 3, 0. And finally, from x plus 2, we know that our final x-intercept is negative 2, 0. Now, let's connect the points while making sure that we have a cubic function which may have a maximum of 2 turning points. And also it's positive, so it starts from bottom left and ends in top right. So I think naturally connecting these points, we'll have a graph something like, it's a different color, going from the bottom left, and we need to turn once between the first two x-intercepts, and then we turn one more time between the second and third x-intercept, and it goes upwards. At this point in our pre-calc 12 lessons, we don't have the ability to find the turning point, so this is enough of labeling. You still need to remember to label the intercepts. That's important information. So make sure that you label all the x-intercepts and the y-intercept. Let's do the final question. Number 5. Find the equation of the function that the graph below represents in the form of p of x is equal to ax power 4 plus bx power 3 plus cx power 2 plus dx plus e. All right, we're given multiple informations here about the x-intercepts and the y-intercept. So let's see what we can do with that. Well, the first information is the x-intercepts must tell you that p of x must be a times x plus 3 times x plus 1 times x minus 2. Right. The x-intercepts tell you the factors of the p of x. But there's something weird about this function, isn't there? The given function is a quartic function because there's 3 turning points. But p of x equals a times x plus 3 times x plus 1 times x minus 2. It seems like a cubic function. So what is wrong here? Well, we need to pay attention to the special property at 2, 0. At 2, 0, the behavior of the graph near the x-intercept is quite different. Compared to negative 3 and negative 1, where the graph simply goes through the x-intercept, at 2, 0, the graph touches 2 and bounces back. So, in case you don't remember, that's called multiplicity of 2. There's multiplicity 2 because it's bouncing at that single point, acting like a quadratic function. What does that multiplicity tell you about the factor? Well, it tells you that the factor must be squared. So now my degree makes sense. My p of x now looks like a quartic function. So let's go on from here and expand p of x. It's quite a lengthy process. Let's do it one by one. X plus 3 times x plus 1, x squared plus 3x plus 1x plus 4x plus 3. Let's expand x minus 2 squared as well. X squared minus 2 times 1 times negative 2, negative 4x, negative 2 squared plus 4. All right, one more step. A times, this is important, difficult foiling, not even FOIL anymore, expansion. We just need to do a lot of repetitions. X squared times x squared is x power 4. And let's do the grouping here using different colored pen. X squared times negative 4x gives you negative 4x cubed. And plus 4x times x squared gives you positive 4x cubed. So negative 4x cubed plus positive 4x cubed will be 0x cubed. Now let's look for the pairs that includes squares. So I think that's going to be x squared times 4, 4x times negative 4x, and 3 times x. 4x squared minus 16x squared plus 3x squared, 7 minus 16 minus 9x squared. If it takes longer than this, no problem. And then we need to find the x ones. So I think that will be the 4x times 4 and 3 times negative 4x. 16x minus 12x plus 4x. And finally, 3 times 4 plus 12. Phew. That took a while. Now my final step is to find the a value. How do I find the a value? Well, one information that we didn't use yet is the y-intercept 0, negative 24. The y-intercept comes from the e value, the constant. Right now, if I suppose that a is 1, the e is 12. The constant is 12. So what should be my a value? Negative 2. Your voice will be included in the video, by the way. So let's put a equals negative 2. So now let's expand it. Negative 2x power 4 plus 0. I'm just going to write it here just to make sure that I don't make the mistake. Plus 18x squared minus 8x minus 24 will be my final format. Negative 2x power 4 plus 0x cubed plus 18x squared minus 8x plus minus 24. Alright, so I think that concludes the video. Magically finished in 34 minutes. That seems like a good trend. I'll see you in chapter 6.